So when we are calculating confidence intervals for data given to us, we're calculating as a proportion. So we don't have the mean and standard deviation, but what we have is enough information that we can calculate the proportion or percentage of data. So this P with a little mark above it, we call this P hat. This is our proportion from a sample. We would write this in decimal form. People can have that in, as many decimal places as they want. I tend to stick with 2 decimal places for my proportion now. Z is still going to be our Z-score. It's from that same Z-score chart that we saw with calculating with the mean and standard deviation. And N is our sample size. And everything else about this, those are the only 3 letters that we have. And we just need to make sure we are carefully typing everything in order to calculate our confidence interval. Notice again, we have that plus or minus sign, just like we did with the mean and standard deviation. So let's take a look at an example here. So we have the proportion of left-handed professional baseball players. So we have a sample size of 59 from the population of all professional baseball players, and 15 of them are left-handed. So we want to construct a 95% confidence interval for this proportion. So our P hat is going to be 15 out of 59. And so I am going to calculate that as a decimal. And I'm going to get 0.25. And it's 0.254, so that 4 is not going to round it up. And I always like to keep my proportions to 2 decimal places. The Z-score for a 95% confidence interval is 1.96. Our sample size, how many baseball players did we look at for this data? Well, it was a sample size of 59 baseball players. All right, so we are going to go ahead and set this up into our equation here. So we have 0.25 plus or minus 1.96, and then all of this in the square root, 0.25, 1 minus 0.25, notice it's in its own parentheses there, divided by 59. And make sure that this whole thing is under the square root when you type this in. So something important to make note of, and we saw this before when we were dealing with mean and standard deviation, this is our MO, or margin of error. So I'm going to calculate my MO first. And again, just be very, very careful when you type this in to make sure that you are typing it in, appropriately and carefully. And so we have 0.25 plus or minus, and for MO, I get 0.110. I always like to do 3 decimal places for MO. Of course, that 0 on the end, we could get rid of it. It's not going to change anything. So we could just do 0.11. And then I'm going to calculate my interval. So the lower bound is going to be the 0.25 minus 0.11. And so that's going to be 0.14. And for the upper bound, I'm going to add 0.25 plus 0.11. And that's going to give me 0.36. So my confidence interval is between 0.14 and 0.36. So I'm 95% confident that the proportion, let me check this out. We are 95% confident that the proportion of all baseball players, I should say professional baseball players, that are left-handed is between 0.14 and 0.36. And so that would be our statement. And again, we can underline the things that are unique. Technically, the proportion would be unique as well, because we're dealing with a proportion here, and then we have it with the values that it's between. And so that would be our interpretation statement to summarize what we're calculating here. So hopefully that helps with our calculations and our interpretation as well.